Hi, it's Mr. Benson here with a video that I've made which goes over perimeter, area and volume. Most of the things that we've done so far and most of the things that you need to be able to do. Now, I've put this together because I'd like you to look over this stuff outside of class time and also to update stuff into your bound reference out of class time. So in here I've got lots of equations that you might find useful. I'll also have some examples in here, but your class time is when you've got to be practicing things where I can help you to actually develop your skills, and it's not the time to be just updating your bound reference. Okay, so the idea that we started off with was with the idea of perimeter. And so perimeter is the total length around the outside of a shape. And really all we've got to do is just add up the side lengths. The units of perimeter are just the units of length. So millimeters, meters, kilometers, whatever the question has. Now, there are a few things to think about when you're thinking about perimeter though, and they are things like some of the things about geometry that you should, probably already be comfortable with. So, for example, considering things like the signs I put on these triangles here. So if you think about the meaning of these little double lines, it's telling you that these two lines on the triangle are the same length. Thinking about things like your types of triangles can be important as well. So, if you're told that it is an isosceles triangle, then you know something about the nature of the sides of that triangle, or an equilateral triangle, you know that everything is the same. Circles. Now, circles are unusual, so they are special and magical because of the relationship between the radius or the diameter to the circumference. So you've just got to really remember to use your equations here and to choose the right ones. The other thing you've got to keep in mind is the ideas of radius and diameter. So the radius is the distance from the center to the edge of the circle, like you can see in the diagram here, whereas the diameter is the distance across the whole circle going through the center, and the diameter is 2 times the radius. And so we can either calculate the circumference from 2 pi r, or we can calculate it from pi d. Arcs are parts of a circle, or a section of the circumference. And if you've got a really obvious arc like a semicircle or a quarter of a circle, then it's pretty easy to work out. But often you'll get questions which are a bit trickier where you don't have a nice angle like that. And so what we've got to think about is how we can figure out how much of the circle we have. So in this case, you can see that it is a quarter, and that's pretty easy to figure out. But if you've got an angle that is different to, a nice easy one like 90 or 180 or 240 or 270 or something like that, then all you need to do is to use the equations that I've shown here. So the length of the arc is the circumference times the angle divided by 360, or 2 pi r times the angle divided by 360. Now, pretty much everyone was really happy with the idea that, if we had a 90-degree angle, that was going to be a quarter of a circle, and we'd divide our answer by 4. Now, just to show how that works, so if we've got L equaling C, sorry, my tablet is deciding to be weird. Okay, so we've got L equaling C times theta over 360. Now remember that I recommend that you always set your stuff out where you write out your equation first, and then you're going to start substituting in values. So we've got C times, now say we're talking about a 90-degree angle or a 90-degree arc, so 90 over 360. Now you can just do that on your calculator and you'll get your answer, and that's fine, but I just want to show you how this actually works out. Now we've got to think about equivalent fractions here. So if you do 90 over 360 on your calculator, what you end up with is 1 over 4. And so effectively we are getting a quarter of a circle, and C multiplied by 1 over 4 is the same as C divided by 4, which is what you all kind of understood how to do. Moving on to perimeter of a sector. Now this is basically just building on what we've done on the previous slide. So we've got to remember that we've got two parts when we're getting the perimeter here. We've got to consider that we have the arc, which goes around the this part of our shape here, but we then also have, so this is the length of the arc L, but then we also have the radius here and the radius here, excuse my dodgy lines. And so we've got to remember that the perimeter of the sector will be the sum of those things. So it's going to be L plus 2 times R. Or if you want to break that down into its all the components, so you can do this in one equation, it's the bottom equation here where we've got 2 pi r times theta over 360, so that gives you the length of the arc, and then plus 2 times r gives you the length of the two straight sides. So then we move on to area. So this is thinking about the number of squares required to cover a shape. And with area, we've got more formulae that we need to think about. We also need to think about the units being slightly different. So when we're thinking about perimeter, we're just measuring a length, so things like meters and centimeters. But when we're measuring area, we've got square units, so centimeters squared and meters squared. Later on, we're going to think a little bit more about how many centimeters, square centimeters there are in a square meter and that sort of thing. So the easy ones are the four-sided figures with parallel sides, so squares, rectangles, rhombus, parallelograms. And all we've got to do there is just multiply the base times the height. And as long as you know those two values, then you're going to be fine. So in my diagram at the bottom, you can see that I've got the base here, and that's just the base of the bottom. Now the height is the height that is the distance perpendicular to the base. So it's not just the side lengths, but it's actually the height from the bottom of the shape to the top of the shape. Now, if you know those two things, it's really easy. If you don't, you might need to use some other techniques to figure them out, but usually they'll be given to you. Triangles, any type of triangle, just a slightly different formula. So if you think about it, a triangle is always half of a square or a rectangle. And so the area of a triangle is just half of the base times height. Now, it even works if they're weirdly shaped. So this one on the bottom right here, so the base here is the base of the triangle, and the height here is the height of the triangle. Now they still can be made into or have the equivalent area to half of that base times the height. So that formula always works as long as you know the height again. If you don't, you might need to use trig or Pythagoras or something like that. Another one that you'll come across is the trapezium. Now the trapezium has two parallel sides of different lengths, and it has, so we need to know the lengths of those two sides, and we need to know the height. And then we can use the formula here, which basically just takes the average of the two side lengths, which we call A and B, multiplies by those by the heights to give us the area. Then area of circles. So again, like the circumference that we were looking at earlier, we've got to think about the special relationship here. So the area of the circle is pi times the radius squared. All you've got to be careful with here is that you identify your radius correctly, so you're not getting mixed up with diameter or circumference or anything else. Area of a sector is relatively easy as well, because all we've got to think about is how much of a circle do we have. Now again, if it's a right angle or a semicircle or something like that, where we can easily go, yes, that's a quarter of a circle, or yes, that's half a circle, then it's pretty easy to work out. But if we find that we have something a little bit trickier, then what we need to do is to go and use this formula here, which is similar to the one we did earlier with the length of the arcs. So for example, if we consider the circle on the right here, well, there are two values that we're given. So we're given r equals 5 centimeters. We're given theta equaling 285 degrees, And so all we need to do is to substitute into our equation. So I'm just going to go A equals pi times, so I've got 5 squared times 285 over 360. Then I'm going to write equals down here, and what I find is that I end up with 62 point, I'm going to round that to 0.2, and it will be centimeters squared for my unit there. So again, if you've got this formula in your bound reference, you'll always be able to work that out. Now the total surface area is the next idea, and this is where we are adding up the surface area of each side of a 3D shape. Now you won't need to think about ones that are really complex, but you've got to consider that there might be a lot of sides that you've got to add up. Also be careful with what the question is asking you, because you might not need to include all the sides. So, you know, if you were going to have to paint a house, well, you don't have to paint the ground underneath the house. So you'd be thinking about the walls and the roof. If you were doing something with the swimming pool, then, you know, obviously a swimming pool has a bottom, but it doesn't have a top. Now there are a couple of special things with total surface area, and cylinders are one that we need to think about. Again, just because of their curved sides. Now what we've got to think about with cylinders is that we've always got the end, which is given by, well, it's obviously it's a circular shape, so the area of that is just given by pi r squared. Now the area of the curved side is given by the perimeter, which is the circumference of the base, multiplied by h. So we've got we've got 2 pi h there, and we've got two ends. So basically, to work out the total surface area of a cylinder, we work out the area of the curved side, which is 2 pi r h, and then we add 2 times the area of the end. Now the area of one end is pi r squared, so the area of two ends is going to be 2 pi r squared. So that formula gives you the total surface area of a cylinder, but it also works for any right prism. Now a right prism is something which has two ends that are the same shape, and then all the other sides are at right angles to that end. And basically the way you can work out the area of that prism is it's the perimeter of the base multiplied by the height, and that will give you the area of the sides, and then you add 2 times the area of the ends. Volume is the amount of space taken up by a 3D object, and then so we're thinking about how many cubes go into something. The units are something cubed, so we might have centimeters cubed or meters cubed. Now a common unit we use for volume is the litre. Now the litre is a decimeter cubed, so a decimeter would be 1/10 of a meter, which is 10 centimeters. So if you think about a cube that's 10 centimeters on each side, that's a litre. Oh no, see, I've done a typo here. So 1 cubic centimeter is a milliliter. If we think about rectangular prisms, pretty easy. All we've got to think about here is that it is just the length times the width times the height. This works for any rectangular prism. Moving on to right prisms and cylinders. So it's a lot like what I was talking about with the total surface area. So cylinders have circular ends, right prisms have ends that are other shapes. So if you think about the shape that I've just drawn down here, so I've got a triangular prism. So we've got the ends here, well here's one end, and the other end is going to be opposite that, which is triangular. Then all the other sides are going to be rectangulars, so rectangles. So we've got sides here and a side in the back. So we've got 2 ends and 3 sides. So to work the volume of this out, all we need to know is the area of an end. and that will be given by the formula for a triangle. And then to work out the volume, we multiply the area of that end, which we will have calculated. Whoops, that was the wrong color. Sorry, I didn't mean to highlight in black. We multiply the area of the end by the height, and we get the volume. So for a cylinder, the only thing that's special here is that the area at the end of a cylinder is a circle. So it is pi r squared for the area of a circle multiplied by h. And just a couple of things that I want you to keep in mind as we're going on with the last few lessons. Sometimes you might need to figure out unknown values. So you might have a triangle where you're not given the height, but you know other information about the sides. You might use Pythagoras for slightly trickier questions like that. Sometimes you need to find unknown values, so especially with problem-solving type questions. So this is where you've got to use your algebra skills, and remember that when we're solving, we do the inverse operations and we do the reverse order of operations. So instead of doing BIDMAS, we would do SAMDIB. And sometimes you've got to express things algebraically. So you've got to think about assigning a pronumeral to the things you're interested in, and you've got to think about how the values relate. And often this is to do with the words in the question. So, you know, if it says, say, the difference of two things, then they're talking about a subtraction. So yeah, thinking about those operations. Okay, I hope this has been a bit helpful. I'd like you to try and update your bound reference with the equations that are shown here. Hopefully most of you have attempted the MathSpace task, and look, all I really want to do is see you spend a little bit of time on that and see how you can go. And if you're not confident with any of these things, please ask me. We'll be moving on in the next couple of lessons just to stuff that is a little bit more advanced than this, but this really covers most of what we've done so far and most of what you need to know.